This lesson corresponds with lesson 6.5, which we took notes on. This one is about multiplying polynomials special cases. So there are some special cases. It's still a multiplying a polynomial, so it's still kind of like FOIL. That's what we're going to use. But we call it a special case because there's going to be some patterns. And if we learn to recognize these patterns, it'll make it easier down the road when it comes time to factor and do other techniques like completing the square. All right. First, what does this mean? So I have 3x plus 10 squared, quantity squared. Quantity squared means something is multiplied times itself. Since it's the whole quantity, that means it's 3x plus 10 times itself, 3x plus 10. All right, so we're going to do FOIL with this. So first would be 3x times 3x would give me 9x squared. Outer would be a 3x times a 10, so that would be 30x. Inner would be a 10 times 3x, which is also 30x. And last would be this 10 times 10, which would be 100. As I've told you many times, you're going to check for O and I to be like terms, and if you can, you combine them together, which will give me 60x. So my answer is 9x squared plus 60x plus 100. Now, this has a pattern, and we call this pattern a perfect square trinomial. Perfect square trinomial. To check and see if your answer is a perfect square trinomial, you need to see if, one, it comes from squaring a binomial, which is what we saw when we did the math, but two, the answer has this pattern. The first term is a perfect square, the last term is a perfect square, and then there's something special about the middle term. So the idea here is if we had 3x plus 10, I'm going to pick a different color. If we had 3x plus 10, quantity squared, this term comes from just squaring 3x. So if you take 3x and you square it, you're going to square the 3 and get 9. You're going to square the x and get x squared. This term comes from just squaring the 10. 10 squared, obviously, is 100. But the middle term, what you're going to do is you're going to take 3x and 10, and you're going to multiply them together. And that is just 30x. But we're supposed to double that to get here to get 60. So we call that twice the product of the two terms. So you take the first term and square it. I say square the first. Take the last term and square it, square the last, and then twice the product of the two terms. And that gives you 60x. Okay, so here's another square of a binomial, and so our answer is going to be a perfect square trinomial. And so now that we know the shortcut, we're not even going to worry about FOIL. We're just going to do this pattern. So we're going to square the first. So if I take 2x and I square it, I'm going to get 4x squared. If I take negative 5 and I square it, I'm going to get positive 25. And then what I'm going to do is I'm going to multiply them together. So 2x times negative 5 would be negative 10x. But then I have to double it. So that would give me negative 20x. So my answer, 4x squared minus 20x plus 25. All right. Then there's one other special case, and it is called the product of a sum and difference. So you'll notice that I have a binomial times a binomial. One of them's a sum, because I have plus. One of them's a difference, because I have minus. But otherwise, the terms are exactly the same. 8x, 2, and 2. Just one's a sum and one's a difference. So let's try foiling this. So FOIL would mean 8x times 8x, 64x squared. Outer would be 8x times negative 2 would be negative 16x. Inner would be 2 times 8x would be positive 16x. And last would be 2 times negative 2, which would be negative 4. What happens with this pattern, this thing called a product of a sum and difference, is outer and inner end up canceling each other out. Negative 16x and positive 16x is 0. So my answer is just the first and the last. So 64x squared minus 4. So one way you can check to see if it fits that pattern is it should only have two terms. Both terms are numbers that are perfect squares. So 64x squared is a perfect square. 4 is also a perfect square. And then there's only a minus sign in the answer. And what we call this pattern is called a difference of perfect squares, DPS for short. All right, so let's check the next example. It's our last one. Is it the product of a sum and difference? Well, I see one's a sum and one's a difference. And they're the same terms, so 3x, 7, and 7. So we should follow that exact same pattern. And so now that we know that there's a shortcut, I can kind of just ignore O and I and do my DPS, my difference of perfect squares, which means square the first. 3x times itself would be 9x squared. Square the last, 7 times itself would be 49. And then take the difference, and obviously that difference is because one's a positive and one's a negative.